Welcome and hello. This is a video tutorial in HEC HMS, and in this lesson, I'm going to be discussing meteorological models. Meteorological models are one of the main components in the project, and their main purpose is to prepare meteorologic boundary conditions for subbasins. These boundary conditions include precipitation, but they can also include shortwave radiation, longwave radiation, temperature, wind speed, pressure, dew point, and potential evapotranspiration. What I have on the screen here is an HMS model, and I've just created the project. I haven't actually even added a basin. So let's go ahead and do that. I'm going to go up to add a basin. I'll just use basin one. And then here's that basin. I'm going to create a second basin by going up to the basin model manager, new, we'll call it basin two. Next, I'm going to create a few sub basins. So let's just click on the sub basin tool, sub basin one. Let's add another one, sub basin two. Up here in basin two, I'll add two sub basins as well, sub basin one and one more. I'll call this sub basin three. Okay. So if I expand the watershed explorer, you can see basin one has a sub basin one and two. Basin two has a sub basin one and three. I'll show you why I did that coming up. Okay. Now for the topic of the lesson here is to add a meteorological model. So I'm going to come up to Components, Meteorological Model Manager, and then click on New. You can give that model a name and a description. Name is required, description is not. Click Create. Now in the Watershed Explorer, I see a meteorological model right here. If I select that meteorological model, we see the different parameters associated with that model down here in the Components editor, and that's in the main Meteorology Model tab. There's also a Basins tab to the right, and this is where we assign each basin to that model, or vice versa. We make that connection here. That includes all subbasins as well. So basin one, of course, would be our contain subbasins one and two. Basin two would contain these subbasins one and three. I'm going to go ahead and say yes to both these connections and then save. Back to the meteorology model tab. In the remainder of this lesson, I'm going to run through and describe these different parameters, but I'm not going to go into the different methods and then those required values as well. That will be saved for a later lesson. This lesson is more about just an overview of the meteorological model and how it ties into HMS. Speaking of which, once a meteorological model is created, we can come up here to the Components editor, Meteorological Model Manager. If we select that model, now we have the option to copy, rename, delete, or update the description. These same options are also available in the Watershed Explorer by right-clicking on that meteorological model, copy, rename, delete, and if we want to update the description, that's the first field down here in the Components editor. We can also import a meteorological model from a different watershed project.hms file by just going up to the File, Import, and then Meteorological Model. What we need to do now is navigate to an MET file. So let's just take a look at the one we have here, which is here, and then here, and then here's the .met file. I would go ahead and select that and then click Select. But that is the model that I already have loaded up. So just go ahead and select a different model if you want to import it. The next parameter down here is the unit system. Our options are metric or US customary, oftentimes referred to as English units. So go ahead and select a unit system for the meteorological model, and then that unit system will be consistently used through all the other parameters for that model. If different parameters are set and then those values are set using a set unit system and then saved, and then the unit system changes later on, then those values and the parameters will appropriately be converted and updated to the new unit system. Next field down is shortwave radiation. This is set to none by default. This represents the incoming radiation from the sun. So the value is going to be 0 at nighttime, and then it's going to be not 0 during the daytime, but it would be reduced in the case of cloud cover. The options for shortwave radiation are shown here. Again, I'm not going to go through all the details in this lesson about all the different options for all these meteorological parameters, but let's just go ahead and select none. When we do, that means there's no shortwave radiation. That's pretty straightforward. If I go ahead and select a different value, say Barstow-Campbell, then what happens is if I can expand the meteorological model icon here in the Watershed Explorer, and I see Barstow-Campbell here, this represents the shortwave radiation for the entire model. And if I expand the subbasins, I now see Barstow-Campbell here. And if I click on that, I would have parameter data to define. Let me go ahead and select a different option. So the next one down would be FAO 56, for instance. In FAO 56, I now have that icon here in the Watershed Explorer for the entire meteorological model. And if I select that, now I have an actual data I need to provide. And if I expand the subbasin, I have a different value, a time series data set in this case, that I need to provide using this FAO shortwave radiation method. What I'm trying to get across is that depending on the type of method you choose for shortwave radiation, and the same is true with long wave radiation, precipitation temperature, whichever values you provide, you may have to provide specific parameter values either at the meteorological model level or at the subbasin level, or both. Something else to point out, which you may have already noticed, is we have a subbasin 1 as part of basin 1 and a subbasin 1 as part of basin 2. However, inside this meteorological model, because we have both basin 1 and 2 assigned to this model, we only have one subbasin 1 listed here. Now, this is somewhat ambiguous because in reality, it actually does apply the data we supply to this subbasin to subbasin 1 in both basin 1 and basin 2. Personally, I would name my subbasins uniquely across all basins to prevent this sort of potential confusion. So that's my suggestion. That's how I would do it. But I just wanted to make mention that the user's manual does mention this potential source for ambiguity as well. I'm going to change that shortwave radiation to none. The next field down is long wave radiation. So as before, we can select none or we can select one of these options. Here we have parameter data at the meteorological level as well as the sub-basin level. If I select a different option for long wave radiation, this is now a situation where we only have data we need to define at the model level. Let's select one more here. Let's go for interpolated. Okay, that's only at the model level. Sutherland. Okay, so this is an example. Sutherland long wave radiation only needs data that applies to the subbasin itself, not to the entire meteorological model level. I should probably mention that the long wave radiation is the energy radiated from the land surface up towards the atmosphere, or energy radiated from the atmosphere down towards the land surface. Also worth mentioning is once you go ahead and select a value from one of these fields and you input data, say the data right here, then if you go back and change the method from like Sutherland to anything else, it's going to remove and delete that parameter data that you have already provided. So just be aware that when you change your selection here in the components editor for the meteorological model, that any data that you provided will be removed. Okay, I'm going to change the long wave back to none. Precipitation is the next field down here, and we have a number of options for precipitation. This includes both the rainfall and the snowfall over the land surface. Whether or not the precipitation is rain or snow, that's determined in each subbasin's snow method. This precipitation method here only determines how much water is falling from the sky. So that's the precipitation field is right here. If I select a subbasin, this snow method right here is what was discussed. So you'd select the snow method and then define the properties, and that would determine whether or not the precipitation was rain or snow. If the basin models used with this meteorological model contain subbasins, which in my case they do, then one precipitation model must be selected. Also, the gridded precipitation must be selected if the Maud-Clark gridded transform method is used for the subbasin. So if I click on subbasin and then transform method, and there's Maud-Clark right there. So some of those sorts of details will be covered when we talk specifically about precipitation. Okay, let's go back to the meteorological model. I'm just going to fire through these last few ones here. Temperature is air temperature. This represents the heat intensity of the air over the land surface. It is a major factor with regard to snowmelt calculations and hence runoff. Next one down is wind speed. This is the wind speed that's measured how fast the air is moving over a certain point. Next down is the pressure method. There's methods here. This refers to the weight of the atmosphere over the land surface. Below that is dew point with a bunch of options here. Dew point represents the temperature below which dew can form. Dew point methods are only necessary when certain evapotranspiration models or long wave radiation models are used. So here's the long wave radiation. Here's the evapotranspiration model. Evapotranspiration is next. It's more important for long-term simulations compared to just a single event simulation. If the meteorological model includes any basins that have subbasins that use a loss method that is either deficit and constant, which is this one here, or gridded deficit and constant there, or soil moisture accounting, this last one, or gridded soil and moisture accounting, that's a situation where the evapotranspiration method must be set. If you notice some of these evapotranspiration methods start with the word gridded, that basically means that each grid cell has its own separate boundary conditions, whereas the non-gridded evapotranspiration methods just assume the same boundary conditions will be applied for each grid in the subbasin. The last parameter here is replace missing, and deals with how to handle missing data from either a grid set or a time series data set. The two options are abort compute and set to default. So abort compute is the default selection here, and this is recommended. And what will happen during the compute if there is missing data is that it will abort the compute routine. The simulation will stop and an error message will be provided to the user. Certain parameters, such as precipitation, if there's a missing data, it can be assumed to be zero precipitation. But there's other parameters which you just very can't easily assume what that missing value would be. That leads me to the next option, set to default. So for instance, with precipitation, it could just set that value to zero if there's missing precipitation data. But for other values, even though you have set to default selected here for replace missing, it may still halt the compute routine and provide the user a error message. All right, well, that was it for this lesson on meteorological models. This was just an introduction where we created a meteorological model. After that, we connected it to the subbasins in the basin models, and then we talked about the different parameters down here in the components editor.